welcome to the Technology for Property Rights presentation, where we will be talking about drone-supported surveys. I am Angela Arnante, the Senior Program Officer of the project, and I'm joined by...
Hi, I'm Engineer Voltaire Tila, Resident Geodetic Engineer of the Foundation for Economic Freedom and a certified drone pilot.
So let me give you a brief background on why we're doing this project. The Philippines has a constricted land market, which is a binding constraint for economic development and poverty reduction. What does this mean? We have 24 million alienable and disposable land parcels, but only half are titled. The other half is composed of untitled residential and agricultural lands. We got this data in a 2004 DNR study. We also validated these figures recently through data gathering at the Land Registration Authority, and the figures are quite similar. There are still 24 million to 25 million alienable and disposable land parcels in the country. So here, I'll show you the number of titles issued annually from 2003 to 2010. So the average is 5,000 titles a year. So this consists of residential, agricultural lands, and commercial lands, and etc. But in 2010, a law was passed to streamline the titling process for residential lands. And this resulted to 50 to 60,000 titles issued per year, which is good, which is great, right? But then we're thinking it would take more than a century to title the remaining parcels. So we're thinking, what can we do to increase the pace of titling? So we also found out that in the titling application, one of the major challenges is the conduct of subdivision survey. What do I mean? It can be costly and can take so much of your time. So now the cost of a subdivision survey for a parcel is around 7,500 to 15,000, depending where you live, your area. And also it would take 10 days to acquire data on a 5-hectare lot. With that challenge, the Technology for Property Rights project was born. It is a partnership between the Foundation for Economic Freedom, which is a public advocacy organization here in the Philippines, and the Asia Foundation, which is an international non-government organization. The goal is to improve the titling process through policies, new approaches, and technologies such as drones. And then a component was born, which is drone-supported surveys. So I'll give you a brief walkthrough of the major activities we've done so far. We did a pilot flight in 2016, followed by policy drafting. This policy basically says that drones are now accepted as alternative tools for surveying. 2017, we did more research, policy consultations, then we developed a training module for GE practitioners and GE students. At the end of the year, 2017, 2 policies were issued by the Land Management Bureau. 2018, we did our first assistance to mass titling activity in Agusan del Sur, the Caraga region. 2019, we finished and rolled out the training module, and we did more assistance to mass titling activities of the DNR. Okay, so here in the pilot flight back in April 2016, we did this in the municipality of Cordova and Cebu along with the Land Management Bureau, DNR Region 7, and Sky Analytics, a Filipino-based drone company, and Micro AR Projects, a US-based drone company. So the result of the study was that drones can meet the accuracy standards set by the government. This is followed by more research and flights in March 2017. This is again to test whether drones can meet the government's accuracy standard in various terrains and various conditions. We did this with Prof. Epifanio Lopez, who is the chairman of the Board of Geodetic Engineering at the Philippine Regulation Commission. The Land Management Bureau is also with us, along with the Geodetic Engineers of the Philippines, and we're joined by our colleagues from the University of the Philippines, Department of Geodetic Engineering, and their Training Center for Applied Geodesy and Photogrammetry. The results of the study showed that the data generated by drones are now comparable to the data generated by the traditional surveying instruments. We flew in Bulacan. We flew over 3 areas, and we had lots of fun under the sun. Months after that, we developed a training module to be used by GE practitioners and surveyors as well as students and the academy, and basically to anyone who wants to venture into drone supported surveys. So the gang is back. We're joined by LMB, Prof. Lopez, and UP. And then in 2019, we finished the training module and had it roll out. So we did it first back in February, and then we rolled out in Luzon, Visayas, Mindanao. We rolled out the training module thrice. One in Luzon with the Bicol University and the Geodetic Engineers of the Philippines. And then for Visayas, we have the University of the Southern Philippines Foundation in Cebu City. And lastly, we have the Caraga State University in Butuan City. Now, I mentioned that we've had several studies. The results of those studies were used as inputs in the development of this policy. And here's a short video about that. Okay, so there you go. For the next slides, I'll be calling Engineer Voltaire Tila to discuss drone-supported surveys.
I'm here to discuss a typical workflow of the drone supported survey. For the project design, the first step is identification of the area to be mapped, then determine the type of drone or UAV to be used, the required accuracy, the number of ground-based equipment needed, such as GNSS receivers and total stations, identification of the appropriate reference control point to be used for the ground control survey, and the number of ground control points to be established, which is at least 3, located at the periphery of the project site. For the reconnaissance, coordination with respective government units such as the NR Regional Office, local government units, and barangay officials. Ocular inspection of the area, recover old and existing corner markers and reference points, check for possible obstruction for drone flight and ground surveys such as communication and NGCP towers. Initial drone flight is also done to check for other obstructions and radio interference. Lastly, inform and get the consent of the residents through the barangay assembly. It is important to have an official of the LGU and a staff of the NR in the orientation of the residents. So the next, flight planning. Here we set the boundary of the flight area to generate the waypoints or flight lines that the drone will follow to accomplish its mission. We also set the front and side overlap of the images, and the recommended overlap for the drone survey is 80%. We also determine the flight duration and the number of required boundaries for the entire flight, and set a corresponding flight altitude for the required resolution or ground sampling distance used for the property survey. The required ground sampling distance is 2 cm or less. Ground control point survey. Ground control points can be established by conventional survey using total station or by global navigation satellite system observation. Static observation is used for GNSS survey. For baseline of less than 5 kilometers, the GNSS observation is at 30 minutes per station. Aerial image acquisition. If the drone map is for property survey, the geodetic engineer must be present throughout the data acquisition process to provide guidance and ensure that the standard operation procedure and plans are followed. Pre-flight checklist is done before takeoff, like check weather condition, the propellers, battery levels, sensors, and memory card of the drone. During the flight, observe the drone at all times. Monitor battery levels, GPS, radio signals, and other air traffic. And after the flight, check for the completeness and quality of the images captured. Image processing. During image processing, the individual images are stitched and georeferenced to a single automosite using the structure from motion algorithm. Accuracy assessment. This is done to verify the accuracy of the drone map, the difference between coordinates of the random points taken on the ground and orthophotos are compared, and the root mean square error are computed. Parcel digitization. Here, we generate parcel formation by digitizing the pre-marked corners visible on the orthomosite. The GIS software like QGIS is used for this process. Survey return preparation. Lastly, the digitized parcels are exported into DXF file format. Then the file is imported to the e-survey plan software of the Land Management Bureau to generate the survey returns like lot description, lot data computation, and technical descriptions. The next few slides are our drone survey activities for mass sighting assistance. This is Barangay Santa Fe Esperanza, Luzon del Sur, which is our pilot site for the drone-supported survey. The site is a residential area with medium to high density. Survey was done last November 2018 with a total of 215 parcels. The generated site was used to identify the lot boundaries of properties and for the generation of survey returns. Our partners for these activities are DNR Caraga Region, Land Management Bureau, UP Department of Geodetic Engineering, Province of Agusan del Sur, the Barangay of Santa Fe, and the Asia Foundation. Next is Barangay Cogon, Manhug, Cebu. The site is a residential area with low to medium density. The survey was done last June 2019 with a total of 50 parcels. Here, the drone-generated automosite was used by the DN Region 7 for the field validation of the subdivision survey. The last one is Barangay Basiad, Santa Elena, Camarines Norte. The site is a coastal, agricultural, and residential area of medium to high density. The survey was done last July 2019 with a total of 102 parcels. Here, the drone automosite map was used by DNR Region 5 as reference in making the subdivision scheme. This is a summary for our title systems. A total of 367 parcels were generated with the help of drone survey. This is a table of equipment and software that we can use for the drone-supported survey. Again, this is Engineer Voltaire Tila, and thanks for listening.
Okay, thank you for that, Engineer Voltaire. Now let me go back to this. So I mentioned that the survey of a parcel costs 7,500 to 15,000 pesos. With drones, we still don't have definite figures. If it really went down or not, or stayed the same, or probably it went higher, we don't know. But we are confident to tell you that from a 10 days data acquisition for a 5-hectare lot, it went down to 2 days. So, lesser days also mean lesser costs. So, apart from drone supported survey activities, we've also had other initiatives. One of which is helping Bicol University in mapping their Ginobatan campus, the orthophotos relevant in their planning and development. We're also monitoring the progress of drone bills filed in the House of Representatives and the Philippine Senate. In fact, last February this year, we met with Congressman Strike Revilla, who's an author of a drone bill. And lastly, with the pandemic, the mobility of the team has been limited, but we still wanted to advocate and disseminate the information on drone supported survey methodology. We conducted do's and don'ts webinar. And here's a short video of that. Final words. Remember that the goal of the project is to improve land titling process through policy, new approaches, and technologies. I think as someone has handled the project for the past 4 years, I think we've made an impact on that. We've seen there's a growing number of geodetic engineers and even non-geodetic engineers who have been employing drone-supported survey methodology in their work. Of course, they employ that methodology as they see fit and probably when the client needs it. And ultimately, the goal is secured property rights. That is to have Filipinos secure titles in a more cost efficient and effective manner. And with that, we end this presentation. Thank you for listening. And if you have more questions or comments, or is there anything you want to let us know, you can always contact us through these channels: Facebook, Twitter, Gmail, and through our website. Thank you very much and have a good day ahead.